Hello, everybody. Here's a little bit of feedback to the problem-solving quiz in the skills module. And as you probably have seen, every student got a slightly different problem, although the questions are all the same principle, but the numbers are different. This is just to show or give you the opportunity to show that you can do these things yourself. So the first question was about preparing a solution, and we have basically sodium chloride that we need to prepare. So we need to prepare 111 milliliter of this solution. And I want to point out, I just randomly have chosen one of these questions. Could have chosen any other, but it just simply shows you how we need to calculate these things. So 111 milliliter or total volume. We want 433 millimolar sodium chloride. We've got the molecular mass of it. We want 0.78% weight per volume glucose in it. We've got the molecular mass for it. And we want also an antibiotic in it, 133 microgram per milliliter. And we've got the stock solution. And in the first question, we are asked, what do we actually need to mix together? So how many grams of sodium chloride, of glucose, and microliter of the penicillin solution. In the second question part, we are asked about the millimole of the sodium chloride and the concentration of the glucose. And in the third part, we do a little bit of a dilution, and we then calculate the concentration of the sodium chloride and the glucose. So how do we go about? So let's start with the sodium chloride, and I've done that already. So we are looking for the grams of the sodium chloride here. So we are looking for grams. We've got the molecular mass of the sodium chloride. So that's 58.4 grams per mole. The grams are in the right place. That's what we are looking for. So we just need to get rid of the mole. And we know that our solution should be 433 millimolar. And we can write this as 433 times 10 to the minus 3 mole per liter. So we see that the mole cancels out. We just have to deal with the liters. And we need to find something that cancels out the liters. And we've got 111 milliliter, which we can write as 111 times 10 to the minus 3 liters. And now the liters cancels out. The only unit that is left is gram, and that is exactly what we were looking for. So we can stop our calculations, and we can just put that into a calculator, and we would get roughly 2.807 gram. Now, I've given it to 3 decimal points here. However, it doesn't matter whether it's 2 or 3 decimal points, because the program will accept a tolerance of 10%. So in this case, it would accept anything between probably 2.6 and around 3.0 gram. So that's what the program would consider as correct. Now, for the glucose, we need to calculate the grams of glucose that we need. And we said we've got a 0.78 weight per volume solution, which means the definition of this weight per volume is 0.78 gram in 100 milliliter. And we can write 100 milliliter as 0.1 liter. And that would give us 7.8 gram per liter. So that would be the concentration of the glucose. We now need to say, okay, we just need 111 milliliter of that. So in 111 milliliter, it's 7.8 gram per liter times 111 times 10 to the minus 3 liter, and that would give us 0.866 gram. Let me just simply highlight what we calculated here. So these would be our correct answers. And finally, for the penicillin, for the antibiotic, we can use the equation of the concentration of the stock solution times the volume of the stock solution. CSVS must be the same as the concentration of the working solution times the volume of the working solution. And we can rearrange that to find VS, the volume of the stock solution that we need. That is CW VW divided by CS. So we need 133 microgram, and micro is written as 10 to the minus 6 gram per milliliter, times 111 milliliter. And in this case, I'm just, I don't bother in converting that, but we could if we wanted to. That is CWVW divided by the stock solution, the concentration of the stock solution here. That is 133 times 10 to the minus 3 milligrams per milliliter. And what we see is that the 133 cancels out, the gram per milliliter cancels out, and what we've got left is 10 to the minus 6 divided by 10 to the minus 3. That gives us 10 to the minus 3, and we still have the unit of milliliter, so that gives us 111 times 10 to the minus 3 milliliter, which of course would be 111 microliter. And that would be our final answer. And it's important to look at the units that we have been asked to give. So we would need to give that as 111 microliters. Okay, now for the second part, where we need to calculate how many moles of sodium chloride does this working solution contain. We can, that is fairly straightforward, because we can look for the mole of sodium chloride. So we are looking for the mole. We want a 433 times 10 to the minus 3 mole, so 433 millimolar solution, and we have a volume of 111 milliliter, which we can write like that. So we've got the mole in the right place. We need to get rid of the liters here, and if we put that into the calculator, we would get 0.04806 mole. And since we have been asked to provide our answer in millimoles, we need to multiply that, basically this number here, by 1,000, and that gives us 48.06 millimole. And of course, it applies again that that the program accepts a 10% error, so it would anything between 44 and 52 millimole would probably be considered as correct. Now, for the molar concentration of glucose, we said that that we are looking for the mole, or 1 mole equals to 180 grams. That's our molecular mass. So we've got the mole in the right place here. We've got a gram here, and we need to multiply that with our concentration. And we set the 0.78 weight per volume percent. We can write as 0.78 gram per 100 milliliter here. and the grams cancel out. We have the unit that is left is mole per liter, and that is exactly what we want. So if we just put that into the calculator, we get a concentration of 0.0433 mole per liter, but we need to give our answer as millimolar, so we multiply that by 1,000, so that gives us 43.3 millimolar. That is the concentration of the glucose. Now, in the final part, in this experiment, we add 46 microliter of this working solution to 414 microliter of water. What is the concentration of the sodium chloride and the glucose respectively? Now, what we can do very easily is use dilution factors in order to calculate that. So we determine the total volume that we create. So we've got 46 microliter of our working solution, and we add that to 414 microliter of water, so that gives us 460 microliters of the total volume, and we can calculate the dilution factor just simply by taking what we have here, the 46 microliter divided by 460 microliter, and the microliter obviously cancel each other out. So we have a dilution factor of 1 in 10. And we can now use that with the calculated concentrations, or with the concentrations that we've been given. So for our sodium chloride solution, we have a 433 millimolar that we had initially. And if we dilute that 1 in 10, then we would get a 443.3 millimolar solution here. For our sodium chloride. So if we dilute that 1 in 10, then it is a 43.3 millimolar solution. For the glucose, we have calculated that our molar concentration is 43.3 millimolar. And again, if we dilute that 1 in 10, then we get a concentration of 4.33 millimolar for this solution. And now we can basically enter our numbers into the spreadsheet, or into the sheet, into the question sheet that we've got. Here it's far too many digits, of course, but I said the program will accept anything within a 10% error range, and this would be the correct numbers that we just calculated. So I hope this makes sense, and thank you very much for watching.